So welcome Mahesh, and welcome everybody who are joining this session today. This is the last session with our for the Terraform series, and this is within association with Alibaba Cloud, specifically for advanced user and also for a basic user who want to start on Terraform, who want to do something great on Terraform on multi-cloud platform, and even if they are a starter, they will get a great context around it. Mahesh has given two nice sessions around it, which are very in depth and very detailed, and handle most of the sorry, most of covers most of the things that you need to start with Terraform. But what is most specific about this last session is that this has a certification link also, and this has Alibaba Cloud certificate along with our multi-cloud for you certificate that you will get instantly as a participant certificate. For Alibaba Cloud, you will have to go to the Alibaba Cloud site. We'll share you the link. It's already there, and we'll show you how to claim it. And then you can take the exam into multiple passes. Like you go through the videos, recording, even the session will be available on the same link from where you have joined on the fifth IR, and the recording will be available. You go through the recording at multiple passes and try to clear your Alibaba Cloud certification. We also keep a note of people who are clearing the certificate for the purpose, like for our partners or clients or anyone who are interested and who want to need some nice person or expert around Terraform. Will definitely contact you from those perspective also. So the first session was Terraform behind the scene hands-on course. Obviously, the name was there. Terraform for Cloud was more around specific around how to use Terraform on cloud. In the first session, Mahesh talked about creating your own provider through Terraform, and then here is specifically mean for setting up everything in the Terraform correctly in the enterprise environment. And Mahesh will also specifically demo on how to set it up on Alibaba Cloud. Why you choose Alibaba Cloud is obviously it's different than AWS, Azure, and Google Cloud, but it's little ahead in terms of because it has been built later than all this cloud. So this has already included all the feature of all these three clouds. So if you are able to do something, or if you are able to demo something on Alibaba Cloud, it doesn't mean that it's not going to, those concepts are not going to work on Azure or AWS or Google Cloud. It's just that you will have to do a little bit of tweak and trick, but the concept will be same and you will be able to apply it. And we'll also demo the session with Terraform Cloud also at the end of the session. Okay. So if I talk about the hosting team, I am Anjani Kumar. I am the founder. Dheeraj Singh is the volunteer evangelist, and he handled most of the evangelism work from US. He's a well-known data guy. Gavaskar is our delivery director, and he handles most of the fifth training and all those practices that we do around training or around engagement or around event and sessions that are happening across the globe. We have teammates Abhishek Gaurav, Dhruv Gupta, Pranjaman, Chinda, Soumya Pranjal, and multiple people, along with multiple evangelists from worldwide. Mrityunjay Garg from Singapore, Abhishek Mishra, he looks after most of the AGO sessions, and multiple people. And we have around now 11,000 plus of supporters across the globe. And those are direct supporter. And if you talk about indirect people, we have a reach of more than 100,000. Uh, this is our, this screenshot was taken a little earlier. It's not the latest one, but the things our story has changed a lot. But this is what and how we are connected to the world, and people connecting to our website or joining our event from these most of the countries. So what are the community benefit when you get here? So every session has a learner certificate, and exams are there for certain session. It will help you upgrade through short sessions, because we know that most of the technology do not get much of the time to prepare for exam and prepare for new changes that are coming in the cloud or coming in the engineering journey. So this become very easy to get you connected with the expert in that area, and you get a glimpse of it, and then through that video you can go and try to navigate around multiple areas that technologist or the senior guy or the person who is a seasoned, who is like a fellow in that area is going to give you, and through that you can get more and more information around that, digging deep in the right direction instead of roaming here and there, taking certificate and doing nothing. From top companies, people are there, hub for educator, learner, job seeker, and people looking for expert, and community evangelism certificate you will also get when you try to share it on LinkedIn, try to make the platform more popular, bring up more people and technologists like you, and training partnership with cloud companies. We have multiple training partners with different cloud companies. Here, this is a free masterclass on Terraform best practices. Hopefully, you can easily go to the fifthIR.com and simply search this event link. So it automatically take you to the latest event, or you can simply search Terraform in any search box which is there on the page, and will take you to the series. Through courses also you can go, and this is the first course which is listed there. You can go there and through in that course all the 3 series are listed. You can take this course from there. We have 4 generation of transformation as guests. You see Mahesh here and multiple people, including Bill Mon, Jeff Barr has already come and given us precious time here, and including Bob Watt, and you see you name a leader who has not come here. So Mahesh is senior associate. He started as a senior associate. His journey is like quite engaging. A change of senior associate technology. He become architect, manager technology, director technology, and now he's a chief engineer at DLT Apps. And it's like a startup journey that he has started going up. And I know Mahesh from years, and the way he has run multiple large engagement in Publicis Sapient has been great, and it's a story to talk about. And obviously that would take another hour or 2 hours to talk around that, right? So the engagement with the client and giving his global impact is great. It's just like respect him a lot. He is a Microsoft certified Azure Security Engineer Associate, certified Kubernetes Administrator. He's an AWS certified Solution Architect, and much more beyond this certification he has with his experiment and with his Medium talk that he does. And you can directly connect with him on Inspired by Tech. This is the certificate that we get today from Multi-Cloud for You. This is a participant certificate, and this is the Alibaba Cloud certificate and the Clouder Day badge that you will get directly from Alibaba Cloud when you pass the exam. So this is an advanced certification from Alibaba Cloud in association with Multi-Cloud for You. You will get the Alibaba Cloud Academy logo and Multi-Cloud for You logo, and you will get directly signed by Alibaba Cloud President, and you will get serial number, and you can attach it anywhere. So Mahesh, over to Mahesh. See, he loved distributed system engineering, and we are great now. We always have been inspired with all his experience and research that he has done in the past. Mahesh, please.
Sounds good. Thanks for the intro, Anjani. Let me just share my screen.
Yes, please.
Can you see my screen now?
Yes, I can. Yeah.
Okay, perfect. Cool. Thank you. So this is the last final edition of the 3-part series. I guess already Anjani has covered a lot about what I do, but as focus heavily on cloud native development, and as currently in my role at DLT, I focus on strategizing, architecting, implementing cloud and DevOps solutions across major cloud providers. So today, agenda would be, I'll just do a quick recap for people who have or haven't attended the past sessions. And then in continuation, today's focus is going to be some of the best practices that you should adopt in enterprise environments. So I'll go through some repo structures that I've come to realize as the ideal for implementations, large-scale implementations, some conventions around modules and stacks and stuff, and then some basic test frameworks that are quite popular and being used these days. So in the last 2 sessions, the first session was focused on behind the scenes, but more around creating your own provider. So if people have missed that, I just encourage go back to the recordings that were streamed, get in touch with Multi-Cloud. But the main focus of that was just basic intro of Terraform, how to use it, the workflow and such, plan, apply, and how to create infrastructure. But at the same time, we spent a lot of time looking at how to actually create your own provider from scratch in Golang, basically. So if you have missed that session, definitely go through it. The second session focused on, is there a problem with the sound? Sorry. Okay.
It's fantastic. Yeah, it's great. Yeah.
It's good. Okay, fine. Sounds good. So the second session was focused on cloud providers, majorly looked at, I demoed some of the AWS and Azure cloud infrastructure, how to provision that using Terraform, how to manage credentials, log in, and apply using some of the tools that I use. Again, today is going to be just based on that foundation. So if you do not follow some of the aspects which I am using, some tools that I use, I just encourage again to go back to this session, because I won't have time to cover how to actually say use AWS, log into the provider, or similarly. I'll cover a bit on Alibaba Cloud, but AWS Azure I won't be covering much. So if you are struggling with that, then you would have to go back to the previous session. We also talked about state management a lot in there, and how to manipulate state and how it works. So if you did miss that session, I'll just encourage you to go there. Modules was something we briefly touched upon, and then today I'll spend a bit more time on some of the best practices. Now, today's focus, as I said, is more on enterprise. So how do you scale this in an enterprise environment? In case of most big enterprises that use cloud, you can look at the infrastructure across multiple layers. So typically at the bottom, you have this core infrastructure that any cloud provider provides. So it's AWS, Azure, or GCP, Alibaba Cloud. They give you the accounts that you can create, the compliance rules, policies, IAM, access, audit. All those sorts of core settings are what you get. And provisioning of that is one layer of the infrastructure when it comes to Terraform. All of that should ideally be managed with Terraform as well. So that's sort of the first layer. Then once you have that core account or subscription or whatever the construct is of the cloud provider, you then provision the network typically, which is the next layer, which includes VPCs, VNets, subnets, firewalls, load balances, all those network components. Once you have the network, the next layer is the infrastructure itself. So Kubernetes clusters, virtual machines, container instances, and databases and such. And that is what I call as infra components. And then finally, once you have all of these pieces in place, you deploy the applications. So typically what you will have in large organizations is many of these elements are managed by different teams. Different teams get involved in setting up core, the network, the infrastructure components, and applications are with this particular structure that I just talked about. So again, this isn't, don't take this as a gospel and sort of be all end all sort of strategy for all your repository structures, but just typically what you will see is in a cloud provider, so whether it's AWS, Azure, or Alibaba Cloud, you have but for that particular cloud provider, you have a set of repositories. So I typically prefix the provider name to the cloud repo, and then there will typically be a modules repository or multiple repositories for modules to maintain your Terraform modules. You'll have the core network and components, which I just talked about in the previous slide. These will be separate repositories, so you can actually manage your core, which is your provisioning of the AWS account or Azure subscriptions and the governance around it. That's maintained separately. Then you have your network repository, which is typically to provision the virtual networks, the firewalls, the VPCs and subnets and all the network components. And then after that, you have your component repo or repositories to provision the stack for Kubernetes clusters or compute machines or databases and such. And then finally, once you have all of these base components in place, then you can have your application level repositories to manage application infrastructure. Now, this is a sort of guidance that you should use. Most likely, as I said previously, you should align your repositories based on your value streams, meaning how these changes are happening in your particular company, how your teams are structured, who manages what, and that basically impacts a lot on how the code repository structure should be created. Ideally, you don't want the same team, you don't want one repository to be used by many different teams. You want and sort of self-contained. And also one big factor is pace of development. So the structure for repositories of a startup probably may not be similar to a big enterprise. So just make sure you look at this, use it as a guidance, but do not just blindly copy it as is, but try and make sure that you create multiple repositories is the idea behind this. And over time, just to refactor as well, I would recommend that you should keep looking at your structure over time and evolve it as is needed. And then once you have your repository structure nailed, I will cover some of the code and how I've used this with a sample soon, but I just want to cover some basic concepts first. So the second aspect of the code structure is the actual infrastructure, the Terraform code itself. So now you have your repositories. The next aspect is how do you structure your code inside the depot. Now, typically what you see is big enterprise environments. You have separate non-production areas and production areas. So I've just drawn a simple example here. So if you were on AWS or AWS, most likely you would have either a production zone and another non-production zone, and you will have a bunch of multiple accounts that run multiple different services or applications within them. So, I mean, I've worked with environments where people have one or two accounts through to hundreds of accounts, AWS accounts, and similarly for subscriptions, you could Azure subscriptions or the GCP projects. I mean, each cloud provider has a different construct, but whatever that unit is, you have in large scale enterprises, you will have multiple of those instances, and each of them will be running their own workload. So, for example, in this case, account one is probably managed by a particular domain. That same application is deployed across multiple environments, and sometimes there are multiple non-production environments too. You have a dev, test, and pre-production and such, and you may have to manage the same infrastructure, deploy it across multiple units essentially. So how do you, in this complex landscape, how do you really align your repository structure or code inside your repository so it works basically? So the simplest thing I sort of do is basically within these accounts, you have different types of infrastructure, right? So different types of applications. Some apps will be container based or Kubernetes based or Lambda function serverless, and then they will have some dependencies. They would need RDS and database instances, SQL, NoSQL databases. They will use buckets, S3 buckets, storage accounts, all of that. So they, depending on the type of the application, you will have a different combination of resources you need to build, and I call that a stack. So one stack is essentially what a particular application needs end to end. It needs essentially. So in this previous example, if you look at this previous diagram that I was just showing, you can see three clear stacks. So there was one example which was ECS with RDS. There was an example with a Lambda with the DynamoDB, and then there was an EKS, which is Kubernetes cluster, which was then using S3 and RDS. So if you were to consider these as three different stacks, which is a combination of these different resources that can be managed using Terraform, and then you deploy them across multiple accounts, right? So for example, stack one, which is ECS RDS in the previous screen, we had it deployed in the non-production account one, and then we had it deployed in the production version of the account one as well, which is, again, the same stack. And then you had stack two, which was the second sort of type of application deployed across two accounts, and so on. So the idea is to create infrastructure in such a way that the same infrastructure blueprint that you write using Terraform as a stack is deployed across multiple environments rather than deploying it one-off in each environment separately. So the first thing to do is, first terminology you need to understand is there is a stack. So you should combine multiple resources into a stack. And then the second thing is you are deploying the same stack across multiple environments, which is called your deployment. So in your code repository structure, you will have a stack, which is where your Terraform code lives on multiple stacks. And those stacks are deployed into your deployments or environments, essentially. So this is how I've seen sort of or aligned my code repositories more recently, is to have in each repository, whether it's the core components, network, or application infrastructure, you have a folder for stacks, which is where you write your Terraform code for creating a Kubernetes cluster, creating your network, creating your DynamoDB and ECS app, or whatever that is. So each stack sort of sets up all the infrastructure resources needed for an application. And then you have deployments, which is where you deploy the appropriate infrastructure. So for example, Kubernetes cluster is deployed in, let's say, account one and account two. Then you basically have the corresponding accounts labeled there, and you put your Terraform, the TFVARs in there, which is where you define the variables for that particular deployment, essentially. I will show a code, some sample code, so you'll understand more clearly how this works. But this is the structure inside a repository, essentially. So you have stacks and they have deployments. Stack is where you write your Terraform, and you have a self-contained set of resources, and then they are deployed across multiple accounts or subscriptions or whatever the corresponding cloud infrastructure calls it, essentially. So this is the main sort of organizing principle essentially when it comes to repositories. Now, if we were to apply this to, again, the same examples as I said previously for AWS or Azure, if I took the example of the core repository, which is, in my case, I call core as the repo that manages AWS accounts, subscriptions, policies, the config rules, anything to do with provisioning an account or an instance of the underlying cloud account integration, and the associated governance policies you need to apply. So if for that particular one, I would have stacks, one for the account, creation of an AWS account in AWS, and then I would have deployments of that particular account. So I would deploy it in the master account, and I have many different accounts I would deploy to them. And any modules that are specific to the core sort of construct or core capabilities, I can put it in that particular folder as well. So aside from a modules repo, you can also have localized modules that are in that repo. If I were to apply the same thing in Azure context, Azure's got a different nomenclature. So it uses management groups and subscriptions and associated policies and stuff. So in that case, my stacks would be something like provisioning management group, provisioning subscription, provisioning log analytics workspaces and such. So those will be the stacks, and then I would deploy them into individual subscriptions under that management group. So it's a slightly different terminology, but again, the same structure works across multiple cloud providers essentially. So that is the main sort of organizing principle of how the code should be organized. So if I go back now, if I show you some code here, essentially, I've set up a code repository here. Just open that up. So for this session, what I've done is I've set up this code repository. Right now, this is primarily for AWS. Can everyone see my screen? IntelliJ IDE, is this the font big enough, Anjani?
Yes.
Go with this.
Okay.
Okay, perfect. All right, cool. So in this particular code repository, if you can see the main level, right? So this repo has got 3 main folders. So one is the stacks, which is what I just talked about. So I have a network stack, which provisions the network components. So VPCs, subnets, and any gateways, NAT gateways and such. And then I have a Dynamo app stack, which is basically deploying a DynamoDB and an EC2 instance or Lambda, whatever is needed essentially. So that to me is a separate stack. And then I have deployments for those stacks. So for example, network, I've got 2 deployments. So I've got a default account, IBD default account. I have a dev account. So these are both AWS accounts. And in there, I have my Terraform.tf vars essentially. Same thing for DynamoDB. So if I have my Dynamo app, I can deploy it. I have it deployed in my IBT default account, which is an AWS account, maps to a pro. And then in there, I have specified the properties that you need to be passed for that particular stack essentially, which is in Terraform. So this is how it's managed essentially. So when I have to basically set up let's say a network in a particular account, I should make sure I create that folder in here and then run this Terraform against that particular account essentially. What I've done in my case is, and I tend to, there are many ways of doing this, and I'll cover some other aspects of doing this. I have a Gradle build, which basically runs through all of these recursively and creates targets for me. So if you look at this, for every stack, it creates a list of targets. So if you've seen the first session, you've got Terraform init, plan, apply. So these are the stages. So this allows me to basically just run this particular target directly without having to type the whole command every time. So basically, this is just a handy script that I use to then use this repository structure to create targets. So I can just run that target against a particular account essentially. So I can do Terraform init, plan, apply right from here within the IDE. Validate is something I'll talk about shortly later on as well. But this is basically how you sort of organize your code in using the structure that I mentioned. Going back to the best practices. So there are 3 or 4 conventions I'll cover, basic ones, which I think I mean, pretty straightforward for most people, but if you're using Terraform for a while. But if you are not, make sure you adhere to these as much as possible. So the first thing is nomenclature. So naming conventions, nomenclature, casing. I tend to use lower cases for almost everything. So resources, the names of the resource, variables, they're all always lowercase, separated by underscores. That's the convention I follow. And then the other aspect is making sure you use variables. So for example, in this case, the VPC resource that I'm creating, it supports enable NAT gateway, VPN gateway. Now, in my case, I could actually just put the values in here, but instead of putting values, since especially when you start to use modules, it's best to just make sure you define variables and then you provide a default value for the variable. So in this case, for example, the NAT gateway and VPN gateway are default disabled, so I'm set to false. But if someone's calling this resource from outside as a module, they can pass this variable and override it if needed. So as much as possible, use variables for values, as well as make sure that you follow a proper, consistent casing for all your resources that you leverage. The second main sort of standard that I tend to follow is that now, and this was not supported previously, but now it is supported essentially. And basically, it's around variable types. So now you can create complex variable types. So what that means is if you are creating a module or Terraform resource, rather than having to define multiple variables for every single type of attribute. So for example, in this case, I have a container group, Azure RM container group. That's the resource I'm creating for Linux. Instead of creating multiple variables, what I am, as you can see from here, is I'm using a single variable called container config, and I'm using the attributes within that particular container config to then pass it to this particular resource. That way, you have cleaner and fewer variables when you're calling this module or resource from outside, rather than having to pass multiple different variables. So this is a handy way of organizing your code in such a way that you have simpler and fewer variables and parameters, and they are all self-contained. So for example, in this case, container config, they are all related to the container itself that is being provisioned. So I'd rather combine all of those properties into one map, one single attribute or value variable, rather than breaking it into multiple attributes. So try and leverage maps and complex object types for variables like this, rather than creating multiple variables, right? So for example, in this case, I could have created 5 different variables for name, for image of the container, for CPU, for memory, but that is not maintainable over time. So try to combine these related attributes into one variable and use maps and complex object types to manage them. Then the third sort of concept is, again, specific to modules, is that when you're writing Terraform modules, we saw how to do a module in the second session. I won't cover how to create a module here, although I will briefly talk through it when I go through the code. But when you're writing your modules, there are some basic principles you should adopt. The first and foremost, is your modules, when you're creating modules, make them opinionated. So what that means is, don't make everything configurable. Don't expose everything as a variable. There should be some defaults, which is to enforce best practices. So for example, just going back to the same container group example, which creates a container sort of instances based on a Docker image. What I'm doing here essentially is that you see that there are some values that are hard-coded and some values that are auto-generated. And that's because I want to enforce certain best practice. So for example, the nomenclature, I want to use CG hyphen and the name that's passed in the location and the environment as part of that name. So I don't want someone to change this dynamically. So rather than providing a var.name here directly, I am creating this automatically inside my module. So that's sort of an opinionated way of enforcing some best practice. The second thing you'll realize is the IP address type is set to private. So basically, I do not want anyone to create public container groups. Whoever uses this model, they will always be constrained to using private address types for their containers. So this is another practice I'm enforcing because that is something that I want to restrict people from doing. And because I'm using private with Azure at the moment, I think the Windows containers do not support private. So I'm also hard coding the OS type. So this is what I mean by opinionated, is that you provide some major the sort of hard code certain attributes, that best practices that you do not want anyone to change. The second aspect is if once you've defined what is the best practice, everything else, try to make it configurable. So, for example, if you look at the location, the resource group name, the network profile ID, these are all configurable variables. Now, in some cases, I can provide default values, as I showed in the previous slide, but even then, you should always still define a variable rather than hard coding something that shouldn't be opinionated. You should always define a variable with a default value. And the last thing is there are a lot of areas where you have to use passwords, secure data across multiple resources and such. Now, one important thing to bear in mind is these should never be stored in Git repositories, nor should ideally they be in any Terraform state as well. So as much as possible, what you should always do is make sure that you are using the native secret management capability. So with AWS, it's the AWS secret manager. With Azure, it is the key vault and such. And so there's a capability in every provider. So any passwords that you need to generate or create or store, use the secret manager with or the appropriate capability within the cloud provider and store it right within your module, essentially. So that's the sort of final aspect of how you should, some best practice you should adopt. And then finally, what you should also make sure is that when you create these stacks or organize your code, do not put too many resources. So let's say if in this example, for example, I have 10, 20 different resources all deployed in one account one. Now, I could deploy all of them using one Terraform stack, or I could split them into different stacks. Now, my guidance is if you are using, if your Terraform state has 100 or more resources, I think it's already too big. And at the same time, if your Terraform stack has fewer than 10 resources, it's probably too small. So make sure there's a fine balance. You need to organize your code in such a way that your resources are distributed evenly across the Terraform state it creates. So, for example, in this case, my Terraform code repo would look something like this. So I would have 4 stacks. I would have a network stack, which provisions the base network, so subnets and the VPCs. I would have an RDS stack for just a database, because RDS is a bit heavy and it's best to keep it separate from the rest of the resources. And I would have a Dynamo app and an RDS app as 2 different archetypes for the applications that are deployed on top, essentially. So it's simpler. Rather than putting all of this in one stack that deploys everything, I am splitting this across multiple stacks. That way, my state for each of them is different. And so my the state file doesn't get too big, essentially. So this is one of the most important aspects. So smaller stacks, smaller state, is happy life, basically. Longer term, it's going to help you a lot. And if you start putting too many resources in one state, you will constantly have the problem of managing them and updating them is going to cause a lot of pain. So going back to my Terraform, if I just now walk through the code that I was just doing previously. Just minimize this, I guess, yeah. So if I just cover this, expand this even further. So in my example, as I said previously, I've just taken the example of a Dynamo app that needs to be deployed. So I have created a module of my own, which sets up a DynamoDB table, basically, which is, again, a NoSQL database that Amazon offer. This can be applied to anything, by the way, any resource that you create, but just in terms of best practice. So for example, in this module, I've got multiple variables. Now, if you notice, there are some variables that are strings, and then some variables that are more complex, like the primary index, secondary index. So rather than splitting this into multiple variables, what I'm trying to do is combine related variables into related attributes into one variable. So in this case, you have this global secondary index. So I am using a single variable called secondary index with attributes or basically it's of a type, it's a map which has multiple attributes that I then reference in here. What that allows me to do is combine all of these into one single variable and simplifies the configuration that I pass. As you can see, some of the best practices already, I've got underscore. I mean, everything is lowercase and underscores. And then there's no hard coding unless there's something that I want opinionated, sort of hard coded. Everything else is done, dynamically, essentially using variables. So that's the first aspect, which is, the module. Now, this module is then invoked from my stack. Basically, any stack will obviously call the module. So let me first show you the two stacks I have. So the first stack is the network, which in this case, all it is doing is using one of the modules that is available on the Terraform registry. So this is quite often, rather than creating my own module for AWS VPCs, I'm just leveraging a well-defined module that's already there. So in this case, I am referencing this VPC module, version 3.11 of that module, and then I've passed in some of the variables. Now, these can again be used, defined as variables and passed from the TF-vars. For now, I've just hard-coded them, but ideally, what you should also do is you would define another variable here for the CIDR block, and then you can pass this CIDR block from your TF-vars essentially, which is what is used at runtime to then provision the VPC. So if I now go to the TF-vars, so for now, right now, I don't have anything in my TF-vars, but if I define this identity 16, then that becomes my definition for this particular network in the sort of the default account. So you can use existing modules that are available on the Terraform registry this way, or you can also put Git links from GitHub and Bitbucket, or you can reference your own modules like you are doing here. So either way, just make sure that you are still following the same best practices that I mentioned previously. Now, if I go to my DynamoDB code, so this is how I'm referencing my module. So the module is defined in this particular folder. So I'm just referencing a local link of this module. And the only variables I'm passing to this module is the entity name and the VPC ID. So although this particular module expects multiple different attributes, since I've already specified some of the defaults, I don't need to pass them again. So I'm basically just passing the ones that I need. Now, if I needed to override them and create another table, then I would have to modify those particular attributes in here and pass them in here. So that's how a stack looks basically. So you have a stack which has multiple resources. So in this case, it's the database. I've got an EC2 instance. As of now, the EC2 instance is commented. I'm creating a Lambda function here as well. And then I've got the provider, which is AWS in this case, and all the vars. So this is my stack, which is then run against a particular account. And the way it is managed is, if you see this name of the stack is 2DynamoDB, is the same name under deployments, which has then a folder for my account where I want to run this. So this default account, if you go to TF-vars, as I said, as you see, the entity name is user and the VPC ID is passed in here for of the VPC that's been set up already in this account to apply that particular code essentially. So this is how you structure your code, and this is how you reference the TF-vars. Now, when you're running this code, as I said previously, I use these Gradle shortcuts that I've created. But if you're not using, if you don't want to use Gradle, you can still run these commands directly from the command line. The way to do that is basically there are a few flags you need to pass as part of your Terraform plan apply. So you would just still do Terraform plan. So let's say if you are in, if I go to stacks and so I would still do Terraform init. Sorry, I just have. DynamoDB. Yeah, sorry. So it's one. Just missed the. Yeah. So pass the state file inside the bucket. Yeah. So for now, what I'll do is I'll just comment out the backend here, because that requires some additional flags. But basically, yeah, you can just do Terraform init, and then when you do Terraform plan, there are some flags you need to pass. So basically, what you have is, because I'm using var files, I need to pass this -var file with the name of the variable file. So in this case, let's say if I'm running this Terraform plan against this IBT default, I will need to pass the value, this particular folders, this particular file link as part of this particular command. So Terraform plan and then the var file, and it automatically run against this particular TF-vars, which has these default values. And that's how, I mean, previously when we were running Terraform, we did not use TF-vars. So I just wanted to point this out as to how you can combine variable files so that you don't hard code them directly into your stack, but you externalize it and run it across different accounts. The reason or the benefit of these TF-vars is that you can then have different values across different accounts. So for example, if I need to run now Dynamo app in a new account, which was a dev account, which has a profile, assuming you have already created the properties files and everything and config that's needed, what I need to do is paste this same file here, and I need to update this VPC ID to the appropriate VPC ID in that particular account, and then I can run this particular code with the Terraform vars here. So basically what it allows you to do is run the same stack across multiple accounts, so across your dev, test, pre-prod accounts, and then create the infrastructure that way. So that's how in short, how you should organize your code and structure your code. Just moving on to the next aspect of some best practices is there's a lot of testing and validation frameworks available publicly, right? I just want to make sure there is not enough time to cover all of these in details, but I just want to give you a good flavor of some key tools that you should be using when you're running your Terraform code. And this is what I run as part of the validate stage in my Gradle file, essentially. So there are three different categories of tools or frameworks that are available. The first one's linting and static scans, which is when you're running your Terraform plan, essentially. So as part of that, you could do either part of Terraform plan or before Terraform plan, basically. It looks at your Terraform code and tells you whether there are any obvious errors. So there are three main tools that I've seen. One is the TF linting, which is basic linting, looking at deprecated syntax for the providers and any obvious errors, instance types you may be using that are not available and stuff like that. So that's something you can integrate into your Terraform checks, TF lint. Checkov and TerraScan are, again, static scanners. They go beyond just the basic deprecation syntax. They look at cloud provider best practices for various resources, how you should be securing them and stuff such. So Checkov and TerraScan both, again, one is built in Python, the other is built in Golang, but they sort of both have similar capabilities when it comes to checking whether your code is sort of follows best practice, and if it has any obvious errors that you can catch in terms of compliance. Then there is the acceptance test, which is when you run your code, if you want to check and validate that it's been set up correctly. There are many tools again. The two main ones I've seen is TerraTest, which is Golang based again, which basically uses Golang code to provision your infrastructure, and then it runs a bunch of tests, again, all written in Golang to validate that. Let's say if you have deployed a virtual machine and set up some Java application on it, then you can do some health checks. You can do, make API calls and see if that it has been set up correctly. So again, it's an end-to-end sort of acceptance test suite. And then similarly, there's Kitchen Terraform, which is more based on an inspect / test kitchen sort of approach, slightly different. So if you've used those tools, then you will be familiar with Kitchen Terraform. And then finally, there is a bunch of tools that do a lot of around what they call as policy as code compliance. Contest is what is based on sort of OPA, Open Policy Agent, sort of a well-known policy engine that can look at your Terraform code and plan to then tell you whether it is violating some basic principles, and it also allows you to write custom policies as well. So things like if you have an S3 bucket or a storage account or a virtual machine, some basic checks you want to apply that are specific to your enterprise setup, you can apply those. It can also be things like naming conventions. It can be things like encryption. It can be things like whether the virtual machine is using certain specific types of AMRs. I mean, many things that you can test as part of this. And then there are two other tools that are similar. One is the Terraform Compliance, which is again Python-based, and allows you to write BDD style tests. And then finally, HashiCorp have their own, which is Sentinel policy as code as an engine as well, which is available mostly for enterprise users of Terraform if you do use them. Again, feel free. You should use at least a few of these. I think the linting and static ones are pretty straightforward. Everyone should use it. Acceptance test is something that you should look into if possible. I know it is a lot of effort, but at least if some basic tests can be automated, that may go a long way. You shouldn't probably do too many acceptance tests. There is some training material in the references at the bottom of this slide. You can go through those videos to understand more of this in detail. And then finally, just wanted to talk about a few automation wrappers that are also available in the market. So the principles I showed you around stacks and deployments, organizing, there are already well-known approaches as well in the market for this as well. If you want to adopt those as well, free to do that. Feel free to do that. But anything and practices, all the practices I've covered will still apply to those tools as well. So TerraGrunt and Atlantis. TerraGrunt is quite popular. Actually, it's been used for many years over time. It is again a similar approach of using modules to combine your infrastructure, and then keeping some of the stuff that I'm doing with Gradle in my example previously. Doing that using Terraform. TerraGrunt just does it for you out of the box. So if you are interested, you could probably follow along and look through the TerraGrunt documentation, try and adopt it if that works for you. It is an opinionated way of doing certain things, so it may not always work for you. So obviously just consider whether it works in your particular use case. And then finally, Atlantis is something that has come up more recently. It is more to use Git-based, pull request-based workflows. So essentially, all the Terraform plan, apply, all of that happens through pull request activities. So it's more for bigger teams who are managing their infrastructure using pipelines and want to automate everything using basically infrastructure as code and pull requests. Finally, just in a nutshell, just to summarize what we've covered today was I talked through some of the way you should organize your repositories for infrastructure as code. As I said, some basic principles is make sure you divide your infrastructure into multiple repos. Don't use one repo to manage everything. Make sure the repos are aligned to how your teams are structured and how work actually happens. Refactor them over time. So if your repos start to become bigger, then try to reduce the size of the repositories and the amount of infrastructure you're managing using that. Primarily because there will be constant conflicts as teams start to merge code over time. And then separate stacks and deployments. As I said, within each repository, make sure your stack is consistent and can be deployed across multiple accounts or subscriptions. I talked to some of the basic standards and principles around how you should name your resources, variables, using lists and maps and different types of complex attributes for managing your infrastructure. Create opinionated modules, as I said, and avoid hard coding. And as much as possible, create smaller stacks with smaller state files, but also make sure they're not too small. And then finally, we went through some of the test frameworks that are available for testing and compliance. With that, I would like to take any questions before we proceed with the AliCloud section. Any questions so far, Anjani, that you've heard? Hello?
Yeah, sorry, Mahesh, you to say something?
I was just asking if there was any questions from anyone, or should we just proceed with the AliCloud section?
Yes, we can proceed. I don't see any question. Maybe let me check again on the YouTube. The channels, there are no question.
Okay.
YouTube, just give me a moment. I'm just checking up.
Yeah.
So, any question, guys, who are on YouTube?
See if there was any.
We'll go and take some time before our message reaches you. But no, there are a couple of questions on the links I have already posted. So yeah, we are good.
Okay, perfect. All right, sounds good. So let me just proceed, continue. So this next 10 minutes, I'm just quickly going to cover how Alibaba Cloud Provider can be used with Terraform to manage infrastructure. So if you basically,
question, but I think we can do it later. Abhishek, yeah, just stay tuned. We'll get into the question hour. And anyone who have any question, they can keep on typing here. Try to collect it. Even who are on the streams on YouTube or on our directly watching on Fifth IR, don't worry. There is a Facebook chat messenger there. Just type in your question, any concern you have. We'll just pick it up and send you right away. Or you can send us through Telegram also or channel. Yes, ma'am.
should I proceed, Anjani? Are we good?
Yes, guys. Yeah.
Okay, cool. So, so before you start, I would say the main thing to do is always run through documentation, right? As a cloud and DevOps person, first thing to make sure is understand what the manual says about the cloud provider. So, for example, in this case, I searched, I just did a Google search, or you can do search Terraform registry as well, and just find the provider. So, in this case, Alibaba's cloud provider. This is the official provider that is available on Terraform. Now, if you look through the documents, I mean, there are many different. You should always read these, ambers and blue notes, because they typically provide a lot of valuable information that you may not, you may run into. So just bear that in mind. In this case, I think it's more around the versions and the fact that the Terraform supports for 12 onward starts after 1.50 and stuff, which is fine. I think that's not a big deal. But if you go through the sample usage, one of the main things typically with every provider is how do you use it. So in this case, authenticating to Alibaba, if you use Alibaba Cloud, I'm sure you understand these different mechanisms, but it is also important to understand how Terraform can be used with those. So with Terraform, again, there are 6 modes of authentication. So static credentials, which is basically just pass the access key in the code itself, or environment variables, which is you set environment variables, again, for this credentials, using shared configuration file, which is similar to AWS's config file approach as well. It works very similarly. Then there is ECS role, assume role, and sidecar credentials, which are, again, different mechanisms of using. Assume role is almost like assuming a particular role that has been assigned. So there are examples in here for all of these and how you should use them. The first thing, as I said, is always start to understand what are the different mechanisms of authenticating, what is the most secure way of doing it, and how you should set it up. So, for example, static credentials isn't secure at all because you're putting the credentials in your code itself. Environment variables are probably okay. Shared credentials are also probably okay. I think assume role is probably the best approach. If you have an instance or something that can assume the role and use those policies, I think that would be really the ideal way of securely using and passing credentials. But go through that. That's the first thing to understand. So with Ali Cloud, you can use these 6 different mechanisms.
You can ping this link in the chat window.
Yes, sure. Yeah. So as I said, read the manual, first understand how to authenticate. So I have done that. In my case, I'm going the most insecure way, unfortunately, and that's more because I just don't. I'm not going to use this in production per se, and I didn't have enough time to build the VM and everything. Oh, wait a minute, where did it go? Yeah, just need to find the code here. There we go. So what I have done in my case is I have set up some sample code which basically uses static credentials just for the sake of this particular. Sorry, not static credentials. I'm using the profile. So I've got a profile set up on my Ali Cloud config. So if you look at Yun, and then there's a config.json. So, this has some configuration. So it's got a profile and the access key and ID, and that's what I'm trying to reference in here to run my Terraform code. The next thing to look at is, what are all the parameters that you can pass? Again, they're related to the previous. So in my case, since I'm using the second mechanism, the bare minimum I need to pass is the profile name, essentially, which is shared credentials. So here, so this is all I need to pass is the profile. Shared credentials file you can pass if you're putting the file in a different location. So that's all about it. Now, the second thing to do is once you've understood how to initialize the provider and you've written the provider code like so, the next thing to do is, okay, look at a resource. So for example, in this case, I'm just looking at a simple resource, which is provisioning a VPC. So again, go through the document and just try to understand the main arguments. So most of the resources, there will be some mandatory attributes. So for example, this resource, VPC resource, the only thing that is mandatory is the CIDR block. Almost everything, or rather everything else, is optional. So you should only set those if you want to change the defaults, for example. Even VPC name, for instance, is null by default, and it is not mandatory either. So you can almost honestly set up a VPC just by passing the CIDR block. And then, but always look through all the attributes and try and understand if there is anything that could impact the security or the posture or compliance of that particular resource. Now, this is a VPC, so not a huge problem usually with just the VPCs. But if you are provisioning something like a database or something, then make sure you go through the full set of attributes and make sure you're securely setting it in a secure manner. You're provisioning it with, network-wise, you're restricting access to it. Make sure that you are also encrypting the data at rest and in transit and such. So just make sure you understand all the security best practices of that particular resource before you provision that. So with my example, I've got the provider. I'm just trying to provision two resources here, VPC1 and VPC2. I've just called it test VPC. I've given some CIDR blocks to it. One of them I'm passing the name, the other is not. There's no name being passed. And then finally, in my case, I haven't set up the backend, but the Ali Cloud provider also supports backends, which I'd mentioned in the previously, if you have missed the section, which basically this allows you to provision, save the Terraform state remotely on the cloud provider. So in this case, you will use a bucket on Ali Cloud and it will store the Terraform state there. You pass key, prefix, and some basic information. It also supports locking using table stores. So that's another thing to bear in mind. You will need to have provisioned that table store beforehand, but you can use a table store table, which is almost like a DynamoDB table, to lock the state and unlock the state when you have multiple people accessing and modifying the state. So this is how you basically set up sort of a basic Terraform code for provisioning infrastructure on Ali Cloud. I ran into some issues with my Terraform, my account on Ali Cloud, so I can't run this myself. But I think Gavaskar was trying to just get this set up. If you are there, Gavaskar, if you can try and run this just for the audience.
Gavaskar, are you there? We call him.
In the meantime, I can try and cover, I guess, some other questions. There seem to be some questions here. I would like to know how to go about managing code. Sorry.
So, shall I? Yeah. Let me share the screen first.
Yeah, in the meantime, I'm just trying to answer one question that came from Namika. I think she's asking roughly how to change certain configuration parameters across environments. She's asked the example in context of load balancer ports, I guess 443 versus 80. So yeah, absolutely. Ideally, my recommendation is to keep the configuration exactly the same. So even your ports, if you are it's 4, I mean, ideally on the cloud, everything should be 443. Never use 80 as much as possible. So I would suggest try and keep it exactly how it is, right, all across all, especially when it comes to network security. It's best to just keep it consistent, because then you may run into issues you may not find on lower environments. But if you have to, it is still doable. You create variables basically, and you pass. You can use dynamic blocks and change how the parameters are passed for that particular variable. And then in your TFVARs, you can change the port. So in your TFVARs for dev, you would say the port is 80. In the production or higher environments, it will be set to 443. So it's absolutely doable through code for sure. The way to do it is make sure in your code, in your stack, you use variables, and then from your TFVARs for each environment, you specify different values essentially. I hope that answers the question. Okay, go ahead, Kavaskar.
Yeah. It is unable to share. Anjani, can you make me as a host? Hello? Hello?
Yes, done.
Yeah.
Can you do it?
Yeah, it's not sharing. No, it's connecting.
Okay.
I think some bandwidth issue is there.
Okay, so in the meanwhile, you try to handle that out, and what we can do is like we'll take further questions.
Okay.
Yeah,
So,
there are 2 other questions. I think one from Rohit. He's
asking how about block variable?
Yeah, I didn't understand that block variable in what sense. If you want to come off mute and.
Yes, so I'll unmute Rohit. Rohit, you can unmute yourself now. So until Rohit here. Okay.
I won't. Yeah, I'm not sure if he's there, but sorry.
The another one is, does Terraform support SSO and MFA? This is Charanjit.
Yeah, so the SSO and MFA, it depends on the provider, right? So Terraform itself doesn't. I think I covered that. That was in the first session. Terraform itself isn't implementing any kind of.
Unmuted you also, Charanjit, so you can talk directly. Try unmuting yourself.
Yeah, so Terraform itself doesn't implement the single sign-on or authentication. It is part of the provider. So AWS works authentication, and the provider is implemented by AWS provider. Similarly, Azure, a provider will implement Azure ones. Ali Cloud does its own, right? So because each provider and each cloud provider basically and Terraform provider, they work in conjunction, and it depends on the cloud provider itself as to what works. Now, simple answer to MFA, yes, MFA is supported typically if the cloud provider supports it. So for example, with AWS, if you have certain policies that restrict creation of certain resources, based on MFA and such, yes, it will be supported. So it will ask you for MFA essentially if those policies require you to authenticate using MFA. It all depends on how it is configured and set up, but yeah. It is possible. SSO also, if it depends on the cloud provider. So, for example, AWS SSO is supported by the Terraform provider. So, if you you're someone who is using AWS SSO single sign-on service, which links all the accounts together and lets you sign on from one place. It supports Terraform. The provider supports it, so you can just use AWS SSO login, and then that login will then be associated with the profile, and then you can run your Terraform against that profile. So all again, it depends on the cloud provider, but mostly if the cloud provider supports it, the Terraform provider will most likely support it as well. I see AWS has stopped service.
So yeah, obviously I see AWS stopped support on SSO SML. Okay. Any other question, Guy? Gavaskar, are you able to share your screen now?
No, it's not possible. It's
Okay.
connecting. I think some bandwidth issue is there.
Okay, so is it
That's fine.
also there in your last session that you shared? Can we? So another question is from Navneet. How can we use provisioner? So is it there in your last session, Gavaskar? Can I just replay that session from a point where you can say?
Yeah.
I can do that, right?
Okay. Yes. Yes, you can do that.
Okay. In the meanwhile, I just trying to opening and setting up. Mahesh, can you answer that?
Yeah, so provisioner is something, I mean, if you want to provision, I mean, I think it is for configuring, I mean, what's the best way to describe it? If you want to run something specific as part of your Terraform to manage, instances and such, then you can use provisioners. I personally haven't used provisioners myself, but if there is a specific use case you want to use it, then I mean, we can discuss that. But it is a feature that's available with Terraform, obviously. I haven't used it myself.
So okay, I'm here. I'm just sharing the screen. Gavaskar, you tell me from where I should start. Okay.
Yes.
Sharing my screen, guys. Bear with me. So here we go on. I've already shared the link into chat window where Gavaskar has given this session on specifically around Terraform. So Gavaskar, shall I start from this point 49.10?
Yes.
Here or somewhat
No. Somewhat.
ahead?
Yeah, I get. Yeah.
Here.
Yeah. Yes.
Okay.
Yeah. Yes.
Shall I play it?
Yes.
Yeah, now you see here, I have uploaded some files. Okay. Now you see this file, how we can collaborate is but I didn't explain this here. You can in this demo it is not there. You click this code, you can find the link of this particular repository. You can share that to your students or somebody else, so that what they can do. They can collaborate with your files. Okay, that's all about creating GitHub account. So now this is over. Yes. Now we are moving for proceeding to how to create Terraform cloud account. Okay, already I mentioned that you Terraform, two forms are there in Terraform. Two options are there in the Terraform. Either Terraform CLI command.
Just give me a moment, guys. I'm just trying to run it on a high resolution.
Command line interface, or you can use Terraform cloud. Okay, Terraform CLI, you got to download that tool and you got to install that. You got to work with the commands. Okay, you got to work with some commands out there. You got to work with the commands. So it will take some time again. So what I have done is I have created Terraform cloud account. Okay, so I am going to explain that to you. Now enterprise, in all the enterprise they are using this one. They are not using CLI. So yeah, now I will explain how to create Terraform cloud accounts. Yeah, this is something. Yeah, now again Terraform cloud. Yes, you said Terraform cloud or www.terraform.io will be there. You have to just click that. Now you have to create an account. Okay, you have to create an account. Just you click create an account. Now here, first process is you have to create an organization. That's very important. You can give any name over there. Okay, X, Y, Z, or A, B, C, like that. First you have to create an organization. Then after creating the organization, inside the organization only you have to create our space. Okay, that's the main thing you have to know. Okay, so now I am giving username, password. Yeah, now I'll skip some steps. Yeah, now yeah. So now it is created. Okay, the account is created. So you will be taken to the dashboard. Okay, I told you web interface will be there. Okay, so you have to confirm the email address. And now you see, I am getting the confirmation mail. So now you have to click that so that your account, Terraform Cloud account, will be created. It's created. It's okay. It's not a problem. And now it is created. now you see, I told already. So now first what you have to do is you have to create a organization. That's very important. Okay. Start from scratch. I am clicking. Okay. Now it is your organization is very important. You have to create organization name. You can give any name. Naming is not a problem over here. Okay. So I have created a Gavaskar. Okay. It's organization name. Very good. Gavaskar projects. Now create organization. Yeah, organization is created. Now what you have to do is you have to create a workspace. Okay. So for creating workspace, now what you have to do? If you are using Terraform CLI, you have to use Terraform init command. You have to use. See here, very simple. Now see, you have to choose a creative workspace. Listen carefully. This is very important process. Now, okay, version control. You have to choose or version control workflow. So you have to choose the workflow. Okay, what type of workflow? I am going to default workflow. Yes. Okay. Now you see, you have to provide the you see this is the place where you have to provide the GitHub account. Is there no GitHub, GitLab, GitLab, or DevOps? These are the 4 options present. Now my source code is present in GitHub, so I have to provide GitHub account over here. That's very important. Now this is the process of linking the GitHub account with Terraform Cloud. Okay. Now github.com, and you have to provide your username and password. Already you have created GitHub account. Here you have to provide the username and password. So your GitHub account will be linked with this Terraform Cloud. Okay, your GitHub account will be linked with Terraform Cloud, and so that what are the repositories present in the particular GitHub account will be accessed from here. Okay, that's the main step you have to remember here. So again, I will skip some steps. So it will take some time for security authentication. Yes. Okay. Yeah, now it is done. Yes, now you see github.com. Yeah, now it is asking for username and password of your GitHub account. Okay, if you are using the Azure DevOps, it will ask account username and password of Azure account. Okay, now we have to provide username and password. Yeah, now it is authenticated. So you'll get the verification code. Yeah, now it is you have to copy that verification code and you have to provide it over the Terraform Cloud accounts. Yes. Yeah, we have to provide. Okay, now it is ready. So now the Terraform. Yeah, now it is ready, I think. Yeah. Yeah, now version control workflow. Initializing. So I'm getting some error. Okay, I have to access that. Okay. Yeah, now you see the Terraform Cloud is verified with the GitHub. So you see my project, my repo, you see Gavaskar project. This is a repository which I created in my GitHub repository. It is coming over here. My repo is the repository which I created. Okay, you understand? This is my Gavaskar project is the username of GitHub, and this is a project. My repo is the repository which is present in GitHub. It is coming over here. Okay. Now you click that. If you click that, now you can. This is the workspace I am going to click. Okay. So that's it. Okay. Now I hope that initial steps are over. We have created Alibaba Cloud account. We have created Terraform Cloud account, and we have created GitHub account also. Now what I have to do? We have to do we have to follow some steps for creating infrastructure in Alibaba Cloud. Okay. So now we can see that. So now this is a hands-on session I am going to have with you. So before that, let me move to the slide and I will explain what I am going to do for this. Yeah. Yeah. Now see here. So infrastructure as a code. This is the configuration file, Terraform file we can tell, or configuration file, or .tf file. Okay, Terraform file will tell us .tf. It's extension .tf, similar to .c file. No, C file will tell us .c, C++ file .c, CPP, like that. No, Terraform file. This infrastructure as a code is a file which is present, which where it is present GitHub. Okay, it's present in GitHub. It's loaded in GitHub. or it is pushed in GitHub. We can tell. Okay. Now what I am going to do is using Terraform, I am going to pull this response configuration file in the Terraform, and in the Terraform, from Terraform, I am going to pull that. I am going to run this file in Alibaba Cloud. Again, I am going to create the infrastructure in Alibaba Cloud. This is the thing. Okay, this is the thing I explained over here. Adding Terraform code in GitHub repository, then configuring Terraform Cloud and running the Terraform file, and infrastructure code is created in Alibaba Cloud. Okay. Now see, this is the infrastructure which I am going to create. Okay, I am going to create virtual private cloud. Virtual private cloud is nothing but a networking. Okay, LAN network is, you can tell it's example LAN, local area network. You see in your department, no, your local area network will be there. So what will be there? Switches will be there. Okay, switches will be there, routers will be there. So that I am going to do here. Okay, this is a sample network I am going to create. See, multi-cloud underscore VPC. It's a VPC name, virtual private cloud. LAN name, we can set as LAN name. Virtual private cloud is nothing but you are going to create a LAN infrastructure. You are going to create a LAN infrastructure in a private workspace. Okay, we can say private workspace of any cloud service provider. So in the cloud service provider infrastructure, you are going to create a network that we will tell us virtual private cloud. Okay, so this is a VPC name. VPC address is 10.0.0.0. This is a CIDR notation I have from SaaS system. This is the VPC network I am going to create, and I am going to create 3 switches. Okay, I am going to create 3 switches. V switch 1, that's MC underscore subnet underscore VP web apps. 10.0.1.0/24 is the IP address, and again another one 10.0.2.0/24. It is a CIDR notation. You are providing IP address in classless interdomain routing notation you are going to provide. Then in virtual switch, 3 switches I am going to create. Okay, it's very simple. I am going to create a LAN network in Alibaba Cloud infrastructure. I am going to create. Yeah, then I am going to create 3 switches. Yes, 3 switches. 3 subnet I am going to create. You can tell this as a subnet. 3 subnet I am going to create in a network. Okay, this is an example I am going to do that. So first what I am going to do is I am going to show, go to the GitHub. I am going to GitHub. Yeah, this is my GitHub. Terraform, yeah, my Terraform sample. This is my, I don't know, main.tf. Terraform file will end with tf. Okay, now you see, this is the code for creating the Terraform, creating the resource in Alibaba Cloud. Now you see here, already I told that for creating the resource, the keyword you have to use is resource. Okay, then the keyword, this is the provider name, Ali Cloud. I told already. If it is AWS, here you have to provide AWS. And this is a resource name. Underscore resource name is nothing but what resource I am going to create. So in this case, I am going to create virtual private cloud. Okay, VPC. I am going to create a LAN network. You can tell that this is a LAN network I am going to create. And the name is name of this particular resource which I am going to create it VPC. Okay. So the name you can tell, identifier, or you can tell this is an identifier. Now we see name. Here I am going to give the name. So multi-cloud underscore VPC. Already I told him, I explained the diagram. You can see that. You see multi-cloud underscore VPC. Okay. And now you see I am going to create another resource. This is another resource. Switch. This resource is switch. Okay. Then again the variable name for this is MC underscore web app. For implementing some web app service, I am going to use this switch. Okay. Now the name is MC underscore subnet underscore web app. Okay. Now again, I am going to give a VPC ID also. Automatically one ID will be assigned for this. That's Ali Cloud underscore VPC dot ID. One for unique identification purpose, this will be assigned for you. And this is very, very important. Okay, CIDR block. CIDR block is very, very important. Assless interdomain routing underscore block 10 dot. This is what 10.0.1.0/24. This is the IP address which I am going to provide for this particular subnet or switch. Okay, so in case of AWS, if you are using, we will tell this as a subnet. We will not tell as switch. Okay, subnet. This is a subnet I am going to create. And availability zone, I already told that availability zone. You see, consider I am going to create a resource in another region of Alibaba Cloud. So single region may contain multiple availability zone. Okay, that's for providing the high availability. They will provide multiple availability zone with the different power backups will be there, different network connections will be there. Okay. So I want to provide which availability zone I am going to deploy this. Okay, this is the availability zone. See, China. I am in Beijing region. In Beijing region, I am going to deploy this. Okay. Now Ali Cloud underscore vSwitch. Okay, vSwitch is another resource I am going to create. It's another subnet I am going to create. This is another subnet I am going to create. I hope that everyone understands this. So very simple. So the configuration file, if you know network terms, you can write the configuration file easily. Okay. Resource is a keyword, and then provider name, the resource you are going to create, the resource name, and the configuration. That is config. This is the configuration you have to provide. Okay. Created main.terraform. Okay. Now what I am going to do is, so I am going to link this Terraform file in Terraform Cloud. Okay. This is Terraform Cloud myself. Okay. This is Terraform Cloud. Before this, one more step is there. So please, I log into Alibaba Cloud account again. You have to create RAM account. Okay. For accessing this, you have to create a resource. You have to create in Alibaba Cloud. Okay. This is so that you need some access. Okay, you need some access. So for that, you have to create a RAM account in Alibaba Cloud. Okay, if it's if in AWS also you have to create RAM account. Here I am going to create RAM account. Yes, I will log in. I will show that how to create that. I will not create now. Already I created. So now. Sometimes it will not. Alibaba Cloud will be slow. So it will take some time. Okay, now. Yeah, now you have to go to console. This is Alibaba Cloud dashboard. You can tell. This is a dashboard, Alibaba Cloud dashboard. So you can find more things over here. Okay, now recently used services will be there, resource alert will be there, monitor will be there. This is a dashboard. Yes. So I'm not going to deal with this dashboard. Okay, now I want to create a RAM account. So I am going here RAM. So resource management. I have to create a user. Okay, so who can create a resource? Yes. So now you see here, uses. You go to uses. Now you see I created for the demo. Now I created Terraform user I created. So I am not going to show that user ID. So if I secret key and secret access key and secret key will be created here. Okay, you can see that. Okay, you see this is this is the access key and secret key will be there. That will not be mentioned here. You cannot see that. Okay, so secret key and access key will be created. So if using that only, what we can do is we can create resources. Okay, so now you see, I am going to create another user. Okay, I am going to create another user. Demo one. Say name I am going to provide. Demo 2. So now you see here the very important thing is you have to provide open API access. This is very, very important. Okay, if you provide this only, the particular user can create a resource in Alibaba Cloud infrastructure. That is very important. Now you click OK. Yeah, now it is ready. Okay, see, it is displaying access key as secret yes. Now you can if you get this, you can create something in this. Okay, now I will delete this actually. Now one more thing you have to provide here. Yes, now create. Now you have to set permission. Okay, that's very, very important. So you have to set permission what this particular user can do. So add permission. You go to add permission. Yeah, now you get to see here to create a VPC. Yes, VPC. You have to go full alien VPC full access. This is the thing you have to do. Now I am not going to provide this. Okay, so this is the thing you have to do. You have to create a RAM account in Alibaba Cloud and you have to set the permission for this particular account. Okay, now I am going to delete this. Yeah. Yes. Okay. Now if I am deleting this Terraform now, it will not work now. Okay. So this is the thing you have to know. This is the prerequisite you have to do in Alibaba Cloud account. Yes. I hope that you understand this. Yes. I shortly will recap what we have done. First, we have created a GitHub account. Then we have created a Terraform Cloud account. Then we have created a RAM account in Alibaba Cloud. Okay. Now what we had to do here is. Now we have to create a workspace. Yes, new workspace. Okay, already you see I created one workspace. Now I am going to run this workspace only actually. No, I'm not going to expose the access key and access key secret. It is so I'm going to run this, but I will show you how to create a new workspace. Okay, just you click new workspace. Yes, and now as usual, you go to version control workflow. Yes, and now you see you have to link the GitHub account here. Okay, as I mentioned in the previous demo, you click this. It's automatically coming here. You see, my repository is coming automatically here. Okay, all the repository will be coming here. just I am now what I am going to. Why it is coming is already I have configured. I have configured this my GitHub account over here. You see, it's my personal GitHub account. I have configured. I didn't configure the account which I created now. I created javascript.projects. It is the account which I created. I didn't configure that. Okay. So now you see, MC_Terraform_sample. Just you click this. Okay. Now you can provide the short description of this particular workspace. Now you see, if I am going to click create workspace. No, you see this is a difference of we are using Terraform Cloud and Terraform CLI. If you are using Terraform CLI, you have to type commands. Okay, Terraform init like that. You have to here you see create workspace. Now it workspace will be created. Already it is there. No, so I will give us workspace name as Terraform sample_. It is there. Okay, now on. Now create workspace. Yeah, now it's ready. Workspace is ready. My workspace is ready. So now what you have to do is you have to set some environment variable. That's about we have created RAM user account. Yes, RAM user account. We have to set that. We have to do here. Okay. Yeah, variables. You have to go to variables and you go here environment variable. Yes, it is there. Now I am not going to provide Terraform variable. So for interface scenarios, no, we will provide this Terraform variable. But here I am not going to provide. This is symbol. VPC I am going to create. So add variable. You can just click add variable. Then Ali cloud. Node. This is underscore access key. Access underscore key. Okay, this is the key. And here you have to provide the access key. Okay, which you have created in RAM account. And again, you have to save this. Now I am not going to provide that. Okay, it's a security sensitive problem. Security issues like that. So I am not going to provide that. Save variable. Now again another one variable. Ali cloud. So if it's AWS, no, you have to use AWS. Okay, underscore secret key. Secret key. Secret key. You have to provide some value over here. Okay, value over here. Now you have to save this variable. That's all. Okay. Now, first initial step is over. Now what I have to do is I have to create an infrastructure. Yes, I have to plan the infrastructure. That's a very, very important thing you have to know here. So by using Terraform, what you can do is you can plan your infrastructure which you are going to create in any cloud service provider. So now you see, for creating a plan, if you are using Terraform CLI, you have to type Terraform plan. This command you have to type. Now you see here, just I am going to start my new plan. Okay. Reason. So if you are given testing, so any reason you can provide over here and start plan. Just you click start plan. So now in this case, it will not be running. Since I didn't provide the correct access key and access key secret, it will not be running. So you see, plan is running. Yes, plan is running. Plan is running. Its plan is displayed. You see, this is the VPC. This VPC will be created. But it is not, you see, when you are running the plan, the resource is not created in the cloud service provider. That's the thing you have to know here. When you are applying that, you see, confirm and apply. The resource will be created in the cloud service provider. Now, in this case, it will not be created. The reason is, I didn't provide the user secret key and access key. Okay. Now, you see, you can see what are the switches I am going to create. You can find, what are the things we are going to do. Before creating actual infrastructure resources in cloud, you can see what are the resources you are going to create. Yes, that's the thing. That's the advantage of Terraform Cloud. Yes. Now, you see, now I am clicking confirm and apply, but it's not run. So I'm not going to do that. It's a very simple process. You see, first you have to create a Terraform file. You have to upload that in the repository. Then you have to configure that in the Terraform Cloud, and you have to run that. Yes, that's it. Okay. Now what I am going to do is, I am going to demonstrate the example which I have done. Okay, see, this is the example I have done.
I think Oscar, I can skip a little.
For you, yeah.
If people are okay.
This is the thing I have done already.
Yes.
Yeah. Now, first I will. I am.
So,
now see,
I will stop this video, and what I will say, right? The code that is here, like obviously we'll attach it into the session also, and the video link also, which the session link also, which Gavaskar has demoed. So it's the way Mahesh was trying to describe was through CLI, and this is through Terraform Cloud, but it's trying to create a resource on a cloud platform. And if you see here with the Gavaskar example, you just have to run that code similar to it, where Gavaskar has fixed here is correct secret key and access key, right, Gavaskar? Yes. And once he has done everything, it will run, execute, and then it will create those resources, actual resources on the cloud. that's what this demo shows. And now, if you want, I will continue, or anyway, we can give you the link. We just give you the gist of where the exact things are there, where you can directly scroll up. I'll come back here and I will show you in the chat where where those items are there, right? So in the chat, few people asked, right? So where is that? Let me go back to chat and I will again show you. So here I'll expand it a little. You see there's a link which is here. This is the terraform.io. So obviously this is the state that Mahesh has discussed about, and then the session link is here. Here the recording and everything is there. This is the link, right, Gavaskar? This is the one, right? Let me rerun it again to show you that if it's correct. So I'll go here, I'll say continue. And this should take you
Yes.
to the
Yes.
to the same session here, and
Yes.
there and here you can take the session directly. We'll attach this into the session also within 1-2 hours, and with all the GitHub repository link that Gavaskar has shared. We'll discuss internally with the team, and then we'll share that to you. Now coming back to the Mahesh session, right? So how you can claim the certificate, right? So and take the exam. So let me take you to the link directly. This link is obviously on 5th IR. You see, it's going to it. How you can connect to this link is either through the sessions. This will be the recent session. You can search on, or you can simply say Terraform, right? And you will see all the sessions which are there. Okay, and this is the one which is happening now. You can also go through courses to the complete series where all three sessions are there. These are the past session that has happened. Let me stop the video, and these are the past 3 sessions that has happened. Let me take this chat window here. So this is the first one, second one, and this one is the last one, where you will see, and you will also get some description around. And then if you go to book slot, uh, you will see it will automatically convert into watch now once the recording is there. Currently there is streaming here, and here you see there is one free certificate to claim. I will share you the the code for the certificate to claim. This is the participant certificate. Once you click the link, it will ask you about name, email, phone. If you have already gone through the process, it will not ask you, just show you. You just have to do click, and then you will be able to do it. So if I click this, it will take me to this page where you will see everything, and then you just accept and next, and then you put the code there. So similarly, if you take this quiz, you just have to go to Alibaba Cloud site directly. Here you come, you create your account. You don't have to do a lot. You just register now. You don't have to give anything for the account. You just have to give the basic details. Once you are there, you go into the currently, because my account is set up a little differently. So see there. See if I get the code. I will say get code. So I'm still waiting for the code, but most probably once you get the code, your exam will start, and then you can take the exam from here. And you can take into multiple passes. It's not like it's just one pass. You can take into multiple pass. You can try it now, and again you can come back and try after watching the video. All the questions which are there are from these 3 sessions, and partly what Gavaskar has talked about from the another session which is there. We'll attach that session here only, so that will be the part of this series. It will also come up here. It will add up as a 4th session where you can directly link into and see what is there, and how you can go to the Gavaskar session or Gavaskar demo directly, and through that you can claim your certificate. Now I'm coming back to the password, the code. Gavaskar, if you have that handy, looks like it's you have that handy. Just give me a moment. I'm just sharing my screen again, and I will take you through that. So, Just bear with me, guys. I'm trying to open that link and I will reshare it. Open up. Yeah. So So now the slide is with me. I'm again sharing with you the code now, and that through that code you can claim your certificate. So here is the code. It's in caps JMTBM. I'm also pasting this into chat window so that you can claim your certificate easily from here. So it's in here. Sorry, looks like it's a document link that has gone. Just hold on. Okay, it's here. So I think you will be able to get this link, and you will get the certificate link into your email also, and you will also get it into it may take some time, but once you are there, once you come back to the same page, you'll also see it here, right? So one free certificate to claim will change into one free certificate to download within 2-3 minutes, and then you can claim. I can get your download your certificate from it, share it to different different platform also, directly link it to it, and that is it. So back to Mahesh.
Yeah, no, nothing. I think that's all we had to cover actually. Yeah.
Okay.
So thanks a lot. Thanks everyone for joining, I guess. Yeah.
Yes. Yeah. Thank you, everyone. And if you have any issues, we have already posted the Telegram channel. You can. Is this for claiming? Yes. So Alibaba Cloud Exam Voucher is actually linked with this course only. So once you go to the, I have already shown you, right? So I will go back again on the same page, right? So share my screen again. So as I mentioned, right? So you simply go to this course and go into courses, search for the first one, which is Terraform, and then go into here the third session. Fourth session will be that we'll add it quite fast now. Gaskar, if you can add that now your session, right? So book slot is here. You just click in, and then from here through this link, this is a directly voucher connected link. So that makes you enable you a free exam on Alibaba Cloud. So through this link, you can directly go to Alibaba Cloud and take the exam free. Yeah, you just have to create your account, and then you will be able to give the exam into multiple passes. So multiple passes are allowed for people who are joining from multi-cloud for you. Ideally, it is not allowed for more than 3 times, but we have made sure that it's allowed the way we are programmed and the way we try to set up the program accordingly, so that it take time to go through the concept, re-review the concept, go through the video of Mahesh and Gavaskar, and then take the exam. And even if you fail, you try it again. And once you succeed, it's okay, because it's little hard than usual than the most of the exam that we provide. Reason being is this has all the concept at the enterprise level that you have to go through. Anything else, or are we good here? Okay. So thank you, Mahesh, for joining today, and thank you, Mahesh, for giving your precious time, and Gavaskar and everyone who joined today. If you have any issues, you can connect to us on Telegram channel. We have already pinned the link. And the recording and the next link will be available there on the same course page. So what is the ID you are looking for? 57631774. Group also, okay. So it's there. You just scroll up the chat window a little up, and you will be able to find out. Again, I will take you to, I'll ping you that course link. So long here. See. So this is the link, and the passcode I've already shared. Then I will go back and send it to the chat windows. So now the link and the series link is also there. You can keep it handy, and this is the certificate code. This is for code to claim your certificate. claim your certificate from from here. So you come here. This is for your participant certificate. This is not the Alibaba Cloud certificate. You will get the Alibaba Cloud certificate from here. And
then I will go back and send you to the chat. So now the link and the series link is all.
You see here, this is the one to which you can go to take claim your Alibaba Cloud certificate. And this is where you go here, and I will also give you the direct link here. You can where you can put your code and then claim your certificate. Okay, so hope this helps, and so thank you everyone. Thank you for joining today. Thank you, Mahesh.
You're welcome.